This is Algebra 1, lesson number 60. We're going to be talking about geometric solids and prisms and cylinders. We're starting on page 242. Okay, on page 242, we have some pictures of geometric solids. Geometric solids are geometric figures that have 3 dimensions. So we have prisms and cylinders and pyramids and cones and spheres. So today we're going to talk about particularly about prisms and cylinders. A prism is a geometric solid where there are 2 faces called bases. They're usually the top and the bottom, and they're identical and they're parallel polygons. And the other faces are parallelograms called lateral faces. The lateral faces intersect in segments called the lateral edges of the prism. So, here is a prism. The top is a polygon. The top is a polygon. This one in particular has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's an octagon. It has identical bases, so here's the top and here's the bottom. The sides are polygons, and they're regular polygons, which means every single one of them has the same dimensions, the same height, the same width. So this would be considered an octagonal right prism. It's called a right prism because the lateral edges, the lateral faces, meet the bases at a right angle. So the altitude of the prism is another word for the height. Prisms are classified by the shape of their bases, not by the shape of their lateral sides or lateral faces. So this one is a right triangular prism because the bases are triangles and the lateral faces meet the bases at a right angle. This is a right rectangular prism. This is a right trapezoidal prism. This is a right pentagonal prism. A cylinder is like a prism, except that its bases are closed curves instead of polygons. So instead of having edges, it has curves. The curved surface between the bases is called the lateral surface. The segment joining the centers of the bases is called the axis of the cylinder. So here's a cylinder. In this case, it's actually a Yahtzee jar. So here's a cylinder. The top is a closed curve. In this case, it's a circle. The sides are a curve, not straight polygons. If we put a rod directly in the center that went from this base to this base, in the center of the circle, that would be the axis. And the height is still called the altitude. Okay? Because the base meets the lateral surface at a right angle, this is called a right cylinder. Okay. This particular cylinder is actually a right circular cylinder because the top and bottom, the bases are circles. It could be an oval, it could be a flower shape. As long as it's curves and not edges, it's a cylinder. In this case, it's a right circular cylinder. Okay, to find the volume of a prism or a cylinder, we find the area of the base and then multiply that times the altitude or the height. Okay? So, here's an example. The area of the base of a right pentagonal prism is 28 centimeters squared, and the length of its lateral edges is 10 centimeters. Find the volume. So the volume is going to equal the area of the base times the altitude or height. In this case, it's the length of the edges. So it's going to be times times the length. So the area is 28. The length is 10. So that's going to be 280 centimeters cubed. So it's cubic centimeters since we're talking about volume, and that would be your answer. The surface area of prisms and cylinders is found by taking the perimeter of the base, times the height or altitude. Okay? So now for the example, we're going to find the lateral surface area of this right prism. And there's a picture in the book. So here's the right prism, whose bases are regular pentagons, and the dimensions are in meters. So according to this, each of the lateral faces is 8 meters wide and 15 meters tall. So if we have a pentagon, which I am not going to try to draw, the widths of each of the faces is 8 meters. It's a pentagon, so there are five edges. So we multiply 8 times 5. That equals 40 meters. That'll be the perimeter. Right? And then it says in the book that the height is 15 meters. So the area is going to be 8 times, the area is going to be 40 times 15, which equals 600 meters squared. Okay, that's it for this lesson. Try the practice problems and let me know if you have any questions. Thanks!